Hello students, welcome to Sri Jayendra's Ring Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 10 of a unit motion in a plane. So let's begin with today's class. Today we are going to discuss about the relative velocity. This is the part 2 of a relative velocity. In the previous class we have discussed that let's suppose this is velocity of one object. Call it A, it's an VA. Another, it's in velocity of B. Then relative velocity of A with respect to B, or I can say a magnitude of relative velocity of A with respect to B can be given as it's a VA minus of VB. So if two objects are moving in the same direction, their respective quantities will be subtracted. Another one, yes, if here two objects are moving in the opposite direction, so they must be added because it is an VA minus of VB, and this minus minus will make it plus VB. Let's say suppose if one object is moving in this direction VA, another object is moving in this direction VB, then relative velocity of A with respect to B, as both are moving in the same direction, this will be VA minus of VB. Yes, this is VA minus of VB. And if two objects are moving at certain angle with each other, this is VA and VB, then magnitude of relative velocity of AB will be equals to root of VA square plus VB square minus of 2 into VA into VB into cos theta. This is the situation. Even one special case was there, that if VA and VB is of same magnitude, let's say V, then their V relative will be, or I should say a magnitude of V relative will be 2 into V into sine of theta by 2. Yes, this is the situation. That all we have learned up till now. Is it clear? Is there anything in which you have any doubts? No? Great. So now we are going to discuss about the two very important applications. Basically it's two very important applications in relative velocity equations. One is the Riemann problem. And another is the reverse Wiener problem. Sometimes reverse Weaver problem is also known as the river and boat problems. Yes, but both are the one or other way. So we are going to discuss about this two category. One is the Riemann problem and another is the reverse Weaver problem. The things or the basic thing remains the same. Yes, only the application changes. So let's check it out. First, it's in relative velocity of rain. Yes, here I have not written, but it is with respect to man. It's a relative velocity of rain with respect to man. That means a velocity of rain as perceived by a man. It's a relative velocity of rain. I hope this is clear. Is it? Great. So let's suppose that rain is falling vertically downward with velocity VR, and a man is there who is walking horizontally on the road with velocity Vm. So here I have seen the situation. This is VR and this is Vm. Let's suppose always the question would be look like this only. In order to protect himself from rain, he must hold his umbrella in the direction of relative velocity of rain with respect to him. This is what I require always. Yes, I need to find out the direction of an umbrella, or in which I should put my umbrella so that I cannot get wet from the rain. So what we can do is let's have a pictorial representation of the same. This is VR, this is Vm. What I want is the VRM. It's in velocity of rain with respect to man. So when I want this, I require it's in VR minus of Vm. So if I draw this diagram, this is Vm and this is VR. But what I want a minus of Vm. So this is Vr, and minus of this vector is minus of Vm. So here it is. It's a minus of Vm. It is a minus of it's in Vr. And if two vectors are there, their resultant will be between this only. Yes, so this would be the VRM. Now, let's suppose I am interested in two quantities. One in the magnitude of VRM, that means the velocity of rain with respect to man, and another is in angle theta. Let's find it out. So while I calculate the VRM, the things will look like this. It's in VR. This is minus of Vm. Here it's in VRM. It's the velocity of rain with respect to man, and this was the angle theta. So as I see that VM and VR both are inclined at 90 degree with each other, so their magnitude will be under root of VR square plus VM square. And one more thing, now angle made by an umbrella to the vertical, it is looking like something like this. It's a VRM, this is VR, this is VM, and this is tan theta. So while I calculate this, it's a tan theta, which will give me an VM divided by VR. So this theta should be is equals to tan inverse of VM is to VR. Yes, this is the final answer. I hope this is clear. Is it? Is it? So can you do this kind of question? Will it be? Let's look at the questions. If rain is falling vertically downward, with the speed of 10 meter per second, with a speed of 10 meter per second vertically downward. Okay, that I have mentioned. With a speed of 10 meter per second. Find out position of umbrella in first case. If person is at rest. Second, if person is moving in positive x direction with a speed of 5 meter per second. And next, if person is moving in negative x direction with a speed of, let's say same speed, it's a 5 meter per second. So these are the questions. Go through it very carefully. Go through this very carefully and let me know what we can do for this, or how should I proceed. What this is that rain is falling vertically downward with a speed of 10 meter per second. I need to find out the position of an umbrella if person is at rest. So the situation is, it's a first part. The situation is that rain is falling like this. It's a velocity of rain, which is probably the 10 meter per second. Yes, it is. And in this case, Vm should be equals to 0. So man is not moving anywhere. So if I observe the situation, let's say here it is the person, and let's suppose here this is the direction of VR. So he should hold his umbrella like this. Yes. So as he has hold his umbrella like this, he is not going to wet by rain anymore. So if I understood, or if I make an angle, then what I can consider is, let's say suppose this is the horizontal reference level X. So with horizontal 90 degree. So with horizontal at 90 degree. Yes. And with horizontal at 90 degree, and what is the magnitude of rain with respect to man? Let's say even this has been asked. Then so what I can do, VRM is VR minus of VM. Now in this case my velocity of man is already 0 and VR is 10 j cap. Ideally it is a minus of 10 j cap, but here we are interested in magnitude only. So this VRM is equals to 10 meter per second. So it's a man will see rain striking at 10 meter per second. Yes, that was the situation. Is it clear? Is it clear? Yes. So shall we move to the next? In the next situation, the situation that is given is that VR is moving, or VR is falling in this direction. It's a 10 meter per second, and person is there who is moving in this direction, and the speed of a person, it's a 5 meter per second. This is a person is there who is moving in 5 meter per second. So if I draw the situation, the things should look like something like this. It's a VM, velocity of man, and this is the direction of VR. Now what I want, it's a VRM, it's a velocity of rain with respect to man. So what I need to do is, I need to simply write this relation. It's a VR minus of VM. So directly or indirectly, what I want, it's a plus minus of VM. This is VR plus minus of VM. So this is VM. What I want a minus of VM. How could I do this? It's a VR, and this is of minus of VM. This is the situation. So to calculate the position of an umbrella, what I know is that this is first vector, this is another vector, so their resultant must be somewhere here. It's a VRM, and while I'm going to keep my umbrella with vertical, it's an angle theta. So if this is VR and this side is VM, even this side will be the VM. So what I can write, it is a tan theta, that is equals to VM divided by VR. The VM is the 5, VR is the 10, it's a 1 by 2. So theta is equals to tan inverse of half. Yes, this is the first situation, but I should draw this in a little more depth way. That suppose the situation was something like this. This is minus of VM, and this is VR. This is the direction where VRM could be find it out, and this was the angle theta. So if I extend this line, then if this is theta, even this angle would be a theta. It is north, east, west, south. Yes. So I should hold my umbrella by an angle tan inverse of 1 by 2 from vertical position in northeast direction. This will be the case. I hope these things are clear. Is it? Now, magnitude, velocity of rain with respect to man. As you can see, Vr and minus Vm both are perpendicular to each other. Vr and minus of Vm both are perpendicular to each other. And when these two are perpendicular to each other, what I need to write? I need to simply add it something like this. It's a Vr square plus Vm square. So that should be is equals to under root of Vr, it's 100 plus 5, it's 25. So this is under root of 125, and 125 can be written as 25 into 5. So this is 5 root 5 meter per second. This is the velocity of rain as perceived by a man. This is the situation. I hope those things are clear. Yes. So if you put on the umbrella something like this, you will be saved because you are moving in this direction. Yes, great. So shall we move to the next question? It's a third question. In this situation, the data was that rain is falling downward. It's a Vr, and this is given as a 10 meter per second, and velocity of man, it is moving in this direction. This is of 5 meter per second. Velocity of man, this is of 5 meter per second. Again, you need to find out the position of an umbrella and relative velocity of rain with respect to man. That I know. So how can I do this? How should I do this? First thing, what I want VRM, which is basically a VR minus of VM, or it is VR plus minus of VM. So at this point of time, the situation is this is VR and this is VM. So if I want to make VR and minus of VM, what I need to do? I need to just produce the negative vector of this. So negative vector of this would be in this direction. This is minus of VM. So this is the situation. This is minus of VM. This is the VR. The resultant of these two vectors should be in this direction. It's a VRM, and this is the angle theta. I hope these things are clear. If this is VM, if this is VM, even this must be the VM. So my tan theta should be equals to VM by VR, and VM is 5, VR is 10, it's 1 by 2. Yes. Now let's look at this more elaborately. That the situation is this is minus of VM, this is velocity of rain, this is VR. The resultant will be something like this in the theta, and the situation is that this is the angle theta. Yes. So if this is angle theta, even this angle would be the same. This is the same theta. That's north, east, west and south. Yes. So person should hold his umbrella by an angle theta. which equals to tan inverse of 1 by 2 with vertical in northwest direction. Yes, and magnitude, it's a VRM, velocity of rain with respect to man. This is under root of VR square plus VM square. And when I say it's an under root of VR square plus VM square, it's an 100 plus 25. It's a 125, which is 5 root 5 meter per second. That's it. Is it clear? Yes, the VRM, or the magnitude of the velocity of rain with respect to man, remains the same, but angle of an umbrella changes, because now in this situation a person is moving in this direction. Yes, so he should hold his umbrella like this. Now I hope these things are clear. Is it? Is it clear? Are you sure? Great. So shall we move to the next category of questions, that is the river swimmer. But before we go, I would like to have two questions, or very short questions. Let's have a look. It's the velocity of one body with regard to another body. What is it? Yes, it's a relative velocity. Yes. Next question. You are very quick. Well done. Keep it up. Next question. What they say is a car starting from a point travels towards east with a velocity of 36 km per hour. So let's have our news first. It's NEWS. A car is moving in this direction with a speed of 36 km per hour. Yes. Another car from the same point travels towards the north. Yes, this is the situation, with a speed of 24 km per hour. Yes, the relative velocity of one with respect to other. Okay, so let's say that this is the car A, this is the car B. What I want, it's a relative velocity of A with respect to B. Here I'm interested in magnitude only, so let's first focus on the magnitude only. It's a velocity or relative velocity of A with respect to B, which can be given as under root of VA square plus VB square. So that should be is equals to root of 36 square plus 24 square. You can easily add this and calculate this. I hope these things are clear. Is it? Is it? Is it clear? Now, shall I add something? Shall I add something to this question? So let's add it up. That in the previous question, find direction of motion of first car A with respect to B, and second car B with respect to car A. Yes, this two are required, car A with respect to B and car B with respect to A. These two situations are required. So how should I do this? So let's have a rough sketch first. The situation was, it's a velocity of A or motion of an A, and this is motion of a B. When I say car A with respect to B, that means what I want, it's a velocity of A with respect to B, VAB. That means I required VA minus of VB. So to generate a minus of VB, I need to produce a negative vector of the same. It's a negative vector of B. It's a VA minus VB. The resultant of this two must be in this direction. Yes, and this is by an angle theta. But if I see this according to the directions, the situation would be, I hope you understand this. This is news. Yes. So motion of a car A with respect to B is in southeast direction. Is it clear? Is it? Great. Next is the car B. Next is the car B with respect to A. So it's a velocity of B with respect to A. This is VBA, which should be VB minus of VA. So if I do this, it's a VB, and this was the VA. Now what I want it's a minus of VA. So this is VA, this is minus of VA. So the resultant of this two would be in this direction. Yes, and this is an angle theta. This is an angle theta. So this is VB, this is minus of VA, and the situation would be something like this. It's a northeast west south. My resultant will be in this direction. It's a northeast direction. So velocity of car B with respect to A is in northwest direction. I hope these things are clear. Is it? Is it clear? So can you do this kind of questions? Will you be able to solve this? Will you? So can it be done by you guys? Are you sure? So shall we move to the next category of question? Let's move then. This is motion of a swimmer in a river. Let's have a look at the different relations on the different situations. So let's suppose that if a man can swim relative to water velocity, which is V, and water is flowing relative to ground with velocity Vr, then the velocity of man relative to ground Vm, its Vm will be given as, basically this is the Vrm, or I should say it's a VMR, which is Vm minus of Vr. This is VMR, velocity of mean with respect to river. So if I calculate Vm, it would be an Vm plus Vr. Now suppose the thing is move like this. It's a Vm and it's a Vr. So what would be the situation? It's a Vm and it's a Vr. So when I consider this, that these two vectors are moving in the same direction, but please understood this, that velocity of man will get support of the velocity of river, because man is swimming in the same direction as the direction of flow of water. So when these two are the same, velocity of man will be increases, and this is V plus Vr. I hope those things are clear. Is it? Yes. Now one more thing. Now the situation is, let's suppose man is swimming in this direction, but flow of river is in this direction. Now in this situation, man is swimming opposite, it's an 180 degree to the flow of a river, and when this happens, its speed is going to decrease. So this is Vm is equals to V minus Vr. I hope these things are clear. Yes, do not misunderstood this, but with the help of the concept that if two vectors are moving in the same direction, then that relative velocity can be find it out by subtracting them two, and if they are moving in opposite direction, they can be added. Yes, it is fact, but here the case is different. When you are swimming in the same direction as a flow of a water, you are will be supported by a flow of water in this situation, and so that your swimming speed will be increased. A reverse is the case when you and river are you are swimming opposite to the direction of flow of river, then your speed will decrease, and that can be calculated as v minus vr. I hope those things are clear. Now the situation is one more situation, that suppose the river is flowing with velocity vr, and the velocity of the boat, even you can consider here as a swimmer, a velocity of a boat or swimmer in still water is vb, and w is the width of the river. Suppose the situation is something like this. Let's say this is river, this is the width of a river. If you are standing at one of the bank, let's suppose here you are standing of the river and wants to cross the river, that means you want to reach somewhere here, probably here or here, something like this. It's a first bank, it's a second bank, so you want to move from first to second. Then what should be done? Now when we understood this situation, we are going to see this two cases. The one of the case will be of shortest time to cross the river, and another approach is the shortest path to cross the river. So this two would be the situation. One is the shortest time to cross the river, and another is the shortest path to cross the river. So this would be the situation. Is it clear? Is it? So let's look one by one. First, to cross the river along the shortest path, that means my path should be minimum. Here the situation is that this is the width of a river that I have mentioned with w, and river is flowing in this direction. This is vr, as a river current has been shown. Now how should I swim so that I can swim with the shortest path? So shortest path that I know is from here to here only, but to reach here I should start swimming with an angle, this, it's an angle alpha. And if I say with the flow of river, it's this angle, this complete angle. Yes. So when I want that I should travel along the shortest path, what I need to do, I need to simply started swimming in the direction which makes a 90 degree plus this angle alpha with horizontal, or I can say even with the flow of a water. I hope those things are clear. Is it clear? Is it? But let's derive something in this regards. The situation was something like this. Let me redraw this. That this is the flow of river, it's a vr, and you are going to start your swimming in this direction. This is the angle alpha. Yes, this is the angle alpha. You are here, let's say this is position A, and you want to reach at this position, at position B. So what can be done? Yes, this is the velocity of boat, and this direction, this is the vr. Yes, and here the situation is that how could I find it out? This angle. So suppose if I observe this triangle very carefully, it's a triangle O, B and A. This is, let me rename this. This is O, B and A. So if I redraw this, it's in cos alpha, or here the theta has been made. So it's a cos theta, which should be a VR by VB, or sin alpha, which would be an VR by VB, and time taken to cross the river. So this is T is equals to width, that means distance to be traveled. This is distance to be traveled divided by velocity, and their velocity can be given as under root of VB square minus VR square. This is one of the approach. This is one of the approach. Now second approach will be how could you cross the river? So what I understand is that this is VB, or a velocity of boat with respect to river. So in this direction it is a VB cos alpha, and in this direction it is VB sin alpha. I hope this is clear. So if you want to cross the river, in this manner, then what you know is, and what you understand is, that speed is equals to distance by time. So my time should be is equals to, you are here, you are desired to be at here, so the speed should be considered that is of VB cos alpha. I hope these things are clear. Yes, because it is the only vertical speed, and even you want a vertical displacement, so this time taken should be is equals to VB cos alpha. Time taken would be equals to, it's an width W divided by VB cos alpha. I hope these things are clear. And if you approach this questions logically, then there is no need to remember this. I hope these things are clear. Yes, so this T is equals to W by VB cos alpha. I hope these things are clear. One more thing I want to relate is that, look at this, this is VR, this is VB sin alpha, and what do you want? You want that you are about to leaving from this point, and you are going to be at this position, because you want the shortest path. So one more condition should be there, that this vector and this vector should be the same magnitude wise. So one more condition to travel in the shortest path would be VR should be is equals to VB sin alpha. Please remember this. This is very important topic. It's a VR that should be is equals to VB sin alpha. I hope those things are clear. Is it clear? Any doubts? Any doubts on this? Is there any? No? Great. So let's look at the next case. The situation is to cross the river in shortest possible time. Here you are going to cover this in shortest time. Previously you were trying to cross the river in shortest possible path. Yes, now let's look at this two situations. Though this is the situation 1 and this is the situation 2. So as you can see that in the first situation, a boat is swimming with certain angle theta, something like this. Yes, and it is traveling this much of distance. While in this situation it is moving in this direction. Now according to the observation, tell me that which path would take a shorter amount of time. So I hope you are pretty sure that we need to choose a second path to cover the river in the shortest possible time. So what I know is that I need to start swimming with a 90 degree with the river. I should jump it by an angle of 90 degree with a flow of river. So this is the speed VB, this is my displacement W. So what I need to do, I need to simply do with this T is equals to width, that is the distance, divided by speed, and the speed of boat will only to be considered. I hope these things are clear. Yes. Now what is drift? Now what actual drift is, that you have been started from this and you are going to ended up by this. So this displacement in horizontal direction is said as the drift. I hope these things are clear. Yes, so drift can be calculated as W into VR by VB, or one more thing or one more approach can be there. Let's suppose this drift is represented by X. Then I can write this, that X is equals to which velocity is responsible for drift. Look at this. When you swim from this position to this position, yes, it is the VB that is responsible to cover the distance W. Now, X is the horizontal displacement. Yes, and for horizontal displacement, only horizontal velocity will be responsible. So here the horizontal velocity is VR only. So this is equals to VR multiplied by T. This is equals to VR multiplied by T. It's a W by VB. Yes, this is how this relation arrives. I hope those things are clear. Is it clear? Is it? So shall I summarize this? Shall I? Let's have a look. If river and swimmer both are moving in same direction, then it's in velocity of men which will be added, VR plus VM, something like this. Yes, this is the relative velocity. Let's represent it by a V. Second, if swimmer is swimming opposite to the flow of river, then the relative velocity, their relative velocity will be equals to Vm minus Vr. I hope these two things are clear. Now the next two approach. First, to cover the river in shortest path. So to cover the river in shortest path, what do you need to do? This is the width of a river. This is the flow of a river. This is VR. You need to jump. You need to jump in this direction. If I take this as a reference, this is alpha. This is velocity of swimmer or velocity of boat. So this is V as cos alpha. This must be the V as sin alpha. So time to cross the river, it's a T that is equals to W by V as cos alpha. In ideal situation, drift would be a 0 because you are going to land it on this position. This is A, this is B. In ideal position, the drift, this would be a 0 because started from here, ended up by here. Yes, is it clear? Is it clear? So to cover the river in the shortest path, you need to just swim by an angle of alpha while with vertical. The second and the next, to cover the river in shortest time. Now you need to cover the river in the shortest possible time. How could you do this? The situation would be that this is the width of a river, this is W, and from here you should start. This is flow of a river, this is VR, and you need to jump. You need to jump directly perpendicular with the VR. This is velocity of swimmer. Yes, so to cover this, what you need to do, it's a T that should be is equals to W divided by Vs. And your drift, because you are going to start it by here and you are going to land it on probably on this situation. So this is the width, or this is the drift, sorry. It's an x which is equals to Vr multiplied by t, and this t should be equals to W by Vs. I hope these things are clear. Is it clear? So can you do this kind of questions? Can you do this kind of questions? One more thing I want to add here, that this is Vr and this is Vs sin alpha. This Vr must be is equals to Vs sin alpha to cross the river in shortest path. Yes? Is it clear? Is it? So can we move to the questions? Are you ready? Let's have a look. If a person can swim in the river with a speed of 5 km per hour and flow of river is 4 km per hour and width of a river is, let's say, 5 km. Find out time taken to cross the river in first shortest path and second shortest time. You want this two situation. Yes, one of the situation is according to the shortest path, you need to cover this, and the one more situation is according to the shortest time, you need to cover this. So let's begin then. Have a rough sketch of it and work on one. It's the first shortest path approach. One of the situation that this is the shortest path approach, that this is the width of a river. As you know that river is flowing in this direction Vr, and to cross the river with the help of shortest path approach, you must start from here. Yes. So here it's a velocity of swimmer which is given as 5. It's a 5 km per hour, and velocity of river is given, I think it is 3 km per hour. No, it's a 4 km per hour. Vr is 4 km per hour. So let's suppose I want an angle. This is the angle. This is 5 km per hour, so this is 5 cos theta. The width of a river is 5 km. This is 5 km. So t, it's a speed, is equals to distance divided by time, and the time should be is equals to distance divided by speed. Now with speed should I calculate? It's a distance is of 5 km and the speed should be of 5 cos theta. I hope this is clear. Yes, is it clear? Is it? One more thing, this is Vs sine theta, and my Vs sine theta must be is equals to Vr. So this is phi multiplied by sine theta should be equals to Vr, and my Vr should be equals to 4. So what I get is sine theta should be is equals to 4 by 5. So I am having a value of sine theta. Can I get a value of cos theta based on this? Do you have any idea? Let me make you clear. This is sine theta. Okay, so this is 4 by 5, this is 4, this must be a 5. Yes, and this must be an x. So this is x. Let's calculate the value of an x in a rough work. It's a 4 square, that means 16 plus x square should be equals to 25. So this x square should be equals to 9, and this x should be equals to 3. Yes, so this is 3. So from here what I can get is the value of cos theta, and value of cos theta, it is a 3 by 5. So this is equals to 5 by 5 multiplied by 3 by 5. This 2 has gone, it's a 5 by 3r would require to cross the river. Is it clear? This is the approach of shortest path. I hope this is clear. Is it any doubts? Any doubts in this? Is there anything? No? Okay. Let's then move to the shortest time. The second approach. The approach of shortest time. Let me redraw the situation again. That this is the width of a river, and this is of 5 kilometer. Here it says that person can swim with a speed of 5 kilometer per hour. And here I want a shortest time. So to travel with the shortest time, I need to jump directly perpendicular to the flow of river. This is Vr, and this is Vm. That is the V swimmer. What I mean. So time taken, it's a W by Vs. This is 5. Again, this is 5 kilometer per hour. So this will require 1 hour. This will require 1 hour to cross the river. This will require 1 hour to cross the river. I hope these things are clear. Is it clear? Okay. One more thing. If they want to add here that find drift as well. Find drift as well. So what is drift? That you are about to start here and you are going to land on here. So this distance basically defines the drift. So this x should be is equals to Vr into t. Vr, it's a velocity of river. What is it? Velocity of river is 4 kilometer per hour. 4 multiplied by time, it's a 1. It's a 4 kilometer of drift. Yes. Is it clear? Great. Okay. One more thing here, in the case of a shortest path. If I have been asked that with what angle swimmer should start swimming, with what angle swimmer should start swimming, and here I'm talking about the angle with respect to river. So as you can see that this is 90 degree. This is 90 degree. Yes. And this is angle theta. Yes. Now what is angle theta? What is its value? If you can observe this very carefully, that this is 90 degree. This 3 and 5, we have seen the magic triangle. This is 53 degree and this is 37 degree. Yes. So this is 5 cos theta. That means this is 3, this is 5, this is 3. So this angle would be a 53. So very important conclusion: with river, swimmer should swim with 90 plus 53. That means 143 degree. With river, swimmer should swim with 90 plus 53. It's in 143 degree. I hope these things are clear. Is it? Is it clear? So, can you do this kind of questions? Will you be able to solve this kind of questions? Can you? Can it be done? Great work. So, this is all about the relative velocity questions. Now, I would like to add certain topics. They are not the part of the relative velocities, but what I can consider is they are the extra. It's an extra topics, or I should say they are the miscellaneous topics. So I have decided it to cover at the last. Now, let's cover this extra topics based on their questions only. So please listen the question very carefully. That suppose a square is there and the side of the square is A. Let's say the side of the square is A, and on every vertices one of the person is there. The question says if each person is moving with speed v towards each other, what should be time at which they will meet and where they will meet? So go through question very carefully. This is a tricky question. They says ki there are 4 person and this 4 person are standing over here, each one at the each vertices, and suppose each person has started moving with a speed v, and when they say with a speed v, that means speed is fixed, no acceleration could be there, or each one and everyone will be moving with the same speed towards each other. Then they want that what should be the time at which they will meet, and the one more thing is where they will meet. So they require these two things: where to meet and when to meet. So what is your answer? Take a time of 15 seconds and just let me know that what should be the answer. Think this very carefully, even focus on this. If each person is moving with speed v towards each other, focus on this. You might get a hint. So what was your answer? Some of you will say that, sir, these people can never meet because they are moving with same speed, and if they are going to not meet at all, then there is no question to find out the time. But this is absolutely correct, because what you assume is that you are assuming that you are moving in this fashion. It is not like this, because they have not said that you need to move on a boundary of the square. What they say is that you should move towards each other. So to move each towards each other, let's have a look and try to understand this. This is very interesting, that when this person is at this position, this person will move in this direction. At that position, this person will be in this direction, so this will move in this. At this point of time, this person will be moving in this direction, so this will move in this. At this point of time, this person will be at here, so this will move in this direction. But in this situation, this person will be in this direction, so it is moving in this. At this point of time, this person is here, so it is moving in this. At this point of time, it is here, so this is moving in this, and this person is at here, so this is moving in this direction. I hope those things are clear. Is it? Is it clear? Now the situation will be start moving like this, and at a certain place, and that certain place, and that certain place will be always the center of a regular polygon where they will meet. I hope this clear. That first, do you clear with this that no, they are going to meet, that is for sure. So let's derive the relations, and we are going to derive the relation with generalized terms, so that even if it is not the case of a square, but it was the case of a triangle or any polygon, I mean a regular size polygon, hexagon, octagon, anything can be derived. So let's have a look that suppose this is the polygon of n sides, and I have just seen this two sides. This is the angle theta. One of the person would be here, another person would be here. This is moving with the speed v, and even this is going to move with the speed v in this direction. So if I look at this, it's a v cos theta, and this is the v. So if I take a relative velocity between these 2 points, what I can have is, it's a speed that should be is equals to distance divided by time, and the time should be is equals to distance. The distance between these two, it's an a upon their speed. Here I'm going to take a relative speed, it's a v minus of v cos theta. This is the time where they are going to meet. Yes, I hope these things are clear. This is the time when they are going to meet. So my first task has been done. A second task is that every time persons will meet at center of regular size polygon. And third, the total distance traveled before they meet. So total distance traveled will be equals to v multiplied by t. This is equals to v multiplied by a upon v into bracket 1 minus of cos theta. This v con, and this is a upon 1 minus of cos theta. I hope these things are clear. Is it clear? So what I can have is that my t should be is equals to a upon v minus v cos theta, and this distance traveled before they meet is the a upon, it's a upon 1 minus cos theta. Now let's make this a generalized term. Replace the theta with 2 pi by n. So this t will represent a upon v minus v cos 2 pi by n, where n is the number of sides of polygon. n is the number of sides of the polygon. So let's say if it is a square, you need to take a 4. If it is a triangle, you need to take a 3. If it's a pentagon, you need to take a 5, and something like this. So the x, the distance traveled, will be is equals to a upon 1 minus cos 2 pi by n. This is the situation which you should consider very carefully, that these two formulas must be remembered, because even one or two another approaches are there, but they are very calculative, or they are very logical approaches. So it may require a larger amount of time to solve this kind of questions. So to do this, this is probably the best possible approach, that you need to remember these two formulas and the things will be done. Yes, so let's try this. Let's move to the our question that was the initially asked, that this was the square and person are standing over here, and the sides of a square, it's an a. So time at which they will meet, let's say they are moving with the speed of v, so t is equals to a upon v minus v cos 2 pi by n. Here the, as it is a square, so I should replace n with 4, so my time should be is equals to a upon v minus v cos 2 pi by 4, it's a pi by 2, and when I say it's a pi by 2, it's a cos 90 degree. Cos 90 is a 0, so this is t is equals to a by v. This is the time. This is the time what they take to meet. Where they will meet? They will meet at center of square, and this is true for every polygon, so they are going to meet somewhere here. And one more thing, what is the distance traveled before they meet? What is the distance traveled before they meet? Then this should be x should be is equals to a upon 1 minus cos 2 pi by n, it's a 2 pi by 4, so this is a upon 1 minus cos of 2 pi by 4, it's a pi by 2, and it's 90 degree, so this is equals to a. So this x must be equals to a. I hope these things are clear. Is it clear? So will it be done? Is it possible to do this kind of question? Is it? Is it? So can you do this kind of questions? Are you sure? Are you sure? Okay, great. Let's move to the second important question in miscellaneous category. Let's suppose that this is the floor and this is the wall, and one of the ladder is there, and let's say that this end is given a name a, this end is given a name b. This is 90 degree that we can observe. This is the angle theta that these people have given. Yes, now what they want is that suppose if I starts making sliding of point B, if somehow I make a situation so that point B is moving in positive x direction, then you might feel that that point A will be moving towards this, and after some time the situation should be look like this, that point A should be at here and point B should be at here. This was the situation. Yes, I hope this is clear. Is it clear? Great. So what they want that set up a relation between velocity of A and velocity of B. This is the requirement. that set up a relation between velocity of A and velocity of B. Now, how could you do this? Is there any idea? So before you go through this, I request you guys to consider one very important thing. Look at this. Let's suppose one of the string is there, and this string having a certain different particles. Suppose the string is moving with a speed of 20 meter per second. Suppose the string is moving with 20 meter per second, and this are the different particles. It's a particle number 1, 2, 3, 4, 5. Here we are considering that we are assuming an ideal string, and when I say an ideal string, that means massless, cannot be stretched or compressed. It cannot be stretched, cannot be compressed, it should not have any mass. Yes, this is the situation. So it is moving with a speed of 20 meter per second. So what should be the speed of 2, or what should be the particle speed of particle 2? It must be the same. Yes, it's a 20 meter per second because they are moving in the same direction. Fourth, even it is same because the spring is ideal one, that means it cannot stretch. So all the particles lying on the same string will be having the same speed. This is the concept behind this. Shall I write this? All the particles on same string will have same speed. So please remember this, very useful. All the particles on the same string will have same speed. Is it clear? Is it? So let me redraw the situation, and we are going to try to solve this question as well. That this is point B, this is point A, this is angle 90, and this was the angle theta. Now what I know is that this point, it's a point B, is moving in this direction, and this is it's in velocity of A. It is moving in this direction. As this is 90, this is theta, this must be a 90 minus of theta. Yes, because it's a triangle. So addition of this 3 must be an 180 degree. Yes. So if I look at this later, can I say this is moving in this direction, and if I extend this would be the angle theta, because this is theta, this is theta, so this would be the VB cos theta, and this angle would be equals to VA cos 90 minus of theta, and I know that cos 90 minus theta would be equals to VA sin theta. Now this VA sin theta and this VB cos theta, can I consider they are on the same ladder? Yes, and as they are on the same ladder, their speeds must be equal. So VA sin theta must be is equals to VB cos theta. So what I can write, it's a VA by VB, that should be is equals to cos theta by sin theta. This is cot theta. This is what you require, relation between VA and VB. Now probably they are going to give you the theta. Put up the value and solve this question. That's it, you did it. I hope these things are clear. Is it clear? So can you do this kind of question? Can you? Is it possible? Are you sure? Ready to move for the next question? Let's have a look. The next question. First, observe the situation very carefully. That let's suppose this two are the rigid supports over here, and in this two supports we have one of the ring, and that ring have been tied up with a pulley system. I hope you understand the pulley system. And this is the string that has been connected, and from here I am going to pull this. From here I am going to pull this. That the ring has been constrained to move in this direction. Yes, it can move in this is angle theta, and let's say that this is the speed of a string, this is Vs. Now what they want is that set up relation between Vs and Vr. So what I can assume is that this is Vr. If I make this component, it's a Vr cos theta. While I am going to move in this direction, then this is moving in this direction. So what I can assume is this is Vs and this is Vr cos theta. Both are on the same string. And as this both are on a same string, what I can have, it's a Vs is equals to Vr cos theta. That's it. You did it. Is it clear? Is it? So can you do this kind of questions? Can you? Okay, great. So let's wind up this session over here only. Yes, this was the last class before the previous year asked questions. In the next class, we are going to cover the previous year asked questions of this topic. So before you go to that lecture, I request please go through all the topics starting from the vectors to the ended up by the relative velocity and this miscellaneous questions. Please do this. Please revise it thoroughly. Yes, please practice as many questions as possible. Thank you. Have a good day. Take care.